Hi guys, we are here to discuss the last part of functions. We're going to look at even, odd and inverse of a function. Okay, so we'll start our journey by looking at what is the meaning of an even function, right? So even function is defined in this way. Any function whose replacement of x with minus x does not affect. That is, f of minus x becomes equal to f of x. It's the same. Is called as an even function. So it doesn't matter whether you put x in it or negative x in it, the answer is still the same. This is called as a even function. Okay, so let's take a look at some examples of it. You can see that x squared plus x power 4 is an even function because whether x is negative or positive, the output is still the same. Or mod x, modulus of x. In fact, you'll notice that for my negative sign to vanish, because that is what the function is doing, negative sign doesn't affect it. So your function should have something in it that converts the negative into positive without changing the magnitude. Usually such things can happen with a even power or a modulus, as at least two examples. Okay, so these terms or this is the way these are the terms you can expect to be found in an even function, even powers of x or moduluses. Okay, now the second thing is I've discussed even functions and the graphs in my graph theory. You can take a look at it, how even functions behave, how is the graph of that. So I'm not going to repeat all of that here, but the bottom line is even functions are going to be symmetrical about y-axis. Even functions are going to be symmetrical about y-axis. So you can take a look at my video on even functions in graph theory. Moving on, the next type of function is odd function. Now, the definition of an odd function is somewhat like this. It says that when you add your f of x to f of minus x, the answer should be 0. F of minus x, that is negative x, plus f of x, the total should be equal to 0, and such a function is called as an odd function. Or if you send this to the other side, you will get f of negative x is negative f of x. Obviously, that is also called as an odd function. Usually, this is the format you use to prove that a function is odd. It's sometimes difficult to prove this. You will take f of minus x, then take negative f of x, and you try to equate them, and you try to prove they're both equal. It is better that you add them, and things will get cancelled, and you'll get the answer as 0. That is the best way. All right, this is how you prove your odd function. Take an example. You have your f of x cubed plus x power 5. So if you take f of x and if you add it to f of x plus f of negative x, you will get x cubed plus x power 5 minus x cubed minus x power 5. Clearly the answer is 0. So it's an odd function. Usually odd functions will have odd powers of x. Usually that's one of the things that you can expect. Now, odd functions are symmetrical about origin. So I've discussed in detail in the graph theory video, how is this happening? Why are odd functions symmetrical about origin? So please take a look at it. I'm not going to take you through the theory here. It's there entirely in the graph theory in the odd functions part. Moving on, the last part of a function is the inverse of a function. So what is this inverse of a function? It is nothing but something that reverses the function. So look at this. I will explain to you using an example. I have written down in layman's terms. So basically it says that when you put f of x, you get an output called y. If you write f inverse of y, you should get the input called x. That is the meaning of inverse. Okay, so f inverse. So in pictorial terms or in terms of notations, you get if f of x is y, then f inverse of y should give you x. This is called as the inverse function. This is called as an inverse function. Now, not every function has an inverse. It's not possible to have an inverse for every function. So a function which is invertible, so a function which has an inverse is called invertible. It can be invertible if and only if it is both one-to-one and onto. That is, it is both one-to-one. If you remember, what is the name? It is into or injective. It is injective. onto, the other name is surjective. So if a function is both injective and surjective, that is one-to-one and onto, then only it is called invertible, and such a function will have an inverse. And these inverse function or these functions are called bijectives. So a function which is invertible is called bijective. A function which is invertible is called bijective. So we will spend a little bit of time in this video trying to understand how do we get the inverse. Okay, so if a function is invertible, then you write f(x) mapping to y, then the inverse function will map from y to x. That's the meaning anyway. So how do we find this inverse function? Okay, so that's going to be our analysis. But in terms of graph, we can understand that, or we will see that f inverse of x, if you want to draw the graph of inverse of a function, it will be drawn by taking the f of x and reflecting it with respect to x equal to y. Let's see an example here. So if I have the red line, which is my f of x, if I want to find f inverse of x, then the inverse will be nothing but the reflection of f of x with respect to the line x equal to y. This is your x equal to y. If you take that as a mirror and reflect it, you will get the blue line here, which is called as the f inverse of x. So now we will move on to find out, okay, we know how to draw the graph and all, but first of all, how do we find the inverse? What will be the equation of this inverse? Now finding the inverses may not always be easy, but we will take the cases where it is simple. But again, realistically speaking, it's not always easy for us to find the inverse. Even if it exists, it is not easy. But we will take one example, which is the simpler case, to see what is the logic behind it. We will take an example of f of x equal to 4x minus 6. The steps to find an inverse is, you write, it is 4x minus 6, you equate it to y and write x in terms of y. If you remember, we already did this when we are trying to find onto, when we are trying to check whether something is onto or not. The first steps are very similar. You equate it to y. So you get x equal to, in terms of y, you will get x as f of y. This f of y will be called as the inverse of x. This f of y will be f inverse of x. This is what it's going to be. So in this example, the inverse of x is x plus 6 entirely divided by 4. This is the simplest way in which you can find the inverse of a function. Okay, now if you apply this logic, and if the expression or an equation is very complicated, somehow you manage to find the inverse. Now to make sure that you have done things correctly, one way to check this is, you find f of f inverse of x. It is also called f circle f inverse of x. Please don't call this O, it is f of f inverse of x. This is the meaning. Or it is sometimes in maths, it's also called circle, f circle f inverse of x. And also find f inverse of f of x. So do this also. If they are both giving you the same answer, and this answer should be x, then your calculation is correct. Let us take the example. If I take f of x, if it is 4x minus 6, then if I want to find my f inverse of x, what will I do? I will first take 4x minus 6 equal to y. So my x will be equal to y plus 6 by 4. This is my f inverse of x. So I will find what is f of f inverse of x. So you'll get this as 4 times x plus 6 by 4, right? Minus 6. And now I will find what is f inverse f of x, which is, in place of y, I'm supposed to write f of x. So this is 4x minus 6 plus 6 by 4. Now if you simplify this, 4 and 4 gets cancelled, and you'll get x plus 6 minus 6, which is x. And here also you'll see that 6 and 6 get cancelled, then you'll be left with 4x by 4, which is again x. Both are giving you the same answer, and the answer has to be x. And hence what we did in finding your f inverse of x is correct. This is one way of checking whether your inverse calculation is correct or not. Okay. An interesting property of inverse is when you find f inverse g. So if you have two different functions, f and g, if you want to take the circle of, or sorry, if you want to take the inverse of f of g of x whole inverse, this is nothing but g inverse of f inverse of x. The order, when you take this inverse inside, the order changes. This is something very interesting. You can use it in some of the questions to simplify things faster. All right. So, well, guys, that's all about functions. I hope you enjoyed the theory behind it. We are not discussing too many problems. As I mentioned, these videos are to make sure and ensure that your theory is very strong. Problems, you have enough problems to solve. You can also post the questions that you're not able to get from any source in the comments. I will try to answer them and give the solutions there. Thank you and see you in the next module.